Okay, guys, so today's assignment, you have mixed problems. So you may not be going just straight from mass to moles or mole to mole, or it's a mix. So you have to be very, very careful on what we have. You have to be very good at identifying what we're given, all right, and what we're looking for. First thing you need to do, make sure we start with a balanced equation. So here's our balanced equation. We have a 2 to 1 to 2 ratio. Now I'm just going to flip this out of the way for a minute so we can get a better look at this. Okay, we have our mole map behind us, which is good. We kind of need that. So first thing you want to do is underline what is given. And how do we figure that out? Determine that by pretty much they're usually going to give it to you as some sort of number. So in this case, it's 101 grams. And the problem after it's 5.5 moles of copper. So you want to underline that and make sure you know what the substance is. It's copper. So I'm going to label that as A. What are we looking for? How many moles of copper to oxide? This is what we want. So substance A is going to be copper. Substance B is going to be our copper to oxide. So this is substance A, substance B. So in what box are we going to be starting in? How do we determine that? Well, you look at substance A. You're either going to have to be in box 1 or 2, and then look what unit it is. It's going to be either in grams or moles here. In this case, it's grams. So we're at box 1. What do we want to get to? We want to get to moles of substance B. So we got to go to here. So the 2 highlighted yellow pieces are the 2 conversions that we're going to need to make. So the first thing after you've established, right, your plan, right, you've looked up your destination. These are the directions you need to take to get to that destination, okay? So take your given, and I always put it in what I call the starting spot, 101 grams, and it's just of Cu. It's just of copper. So I know I have to do 1 and 2 conversions. First conversion, it says to write 1 mole of substance A on top. Okay, well, substance A was copper, so I'm going to write 1 mole of substance A on top. And now I need to figure out the molar mass of this thing. Since it's just Cu, the single element, look on your periodic table that you're given, okay? And we are using this guy here where everybody was rounded off to 2, and we have a 63.55 as the atomic mass, and that is what we're going to have here, 63.55 grams of copper. So that is our first, all right, that is our first conversion. Next, to go from 2 to 3, you have to do this. And this is where we had some people messing up earlier today, and this is where we got to reiterate. What is it saying on bottom? Blank moles of substance what? A. Our substance A was copper. So we have to leave a little bit of space, okay, moles of copper. Substance B, the one that we want to get into, is the copper to oxide. And in the formula above, okay, that is CuO. Now, these little numbers here, these hashtags, they come from the coefficients of that balanced equation. So let's take a look at the balanced equation real quick. We have a 2 and a 1 and a 2. 2, 1, 2. The coefficient in front of copper to oxide is 2, so we're going to write that. The coefficient in front of copper is 2. We have that. Now, that would give us what we wanted, moles of copper to oxide. So let's just make sure our units cancel out. We have grams of copper on top and grams on bottom. Cancel. Moles copper on top, moles of copper on bottom. Cancel. And so we don't get rid of the numbers. You only get rid of those units. So this is the only unit that didn't get canceled out, which is what we need. And then you multiply everything on top, divide by what's on bottom. So some people, like to write it out like this. They wrote it out as, 101 times 1 times 2. They threw that into a calculator and then did underneath divide by 63.55 times 2 underneath. You don't have to do that. Okay, visually, this is essentially what would happen. And so when you throw that into a calculator, it's going to kick out an answer of 1.589 and some change. We'll cut it off at 2 to 3 decimals. And moles of what? CuO, copper 2 oxide. So really, guys, the biggest parts are identifying A and B and knowing what conversions you have to make. All right, you're always going to have to go use this conversion here to go from one substance to a next that has to go based off of that mole ratio from the balance equation, which is important. All right, so let's balance the first guy of number 2. Let's balance the first guy, or let's balance number 2, and then we can get started here. So we have a C, there are 4 of them. We have an H, there are 10. We have an O, there are 2. Over here on this side, 1 carbon, 2 oxygen, 2 hydrogen, and 1 oxygen. If I balance the carbons first, to get a 4, I need to multiply this by 4. Now, since it's whatever you multiply becomes the coefficient, but that coefficient applies to, okay, that whole compound. So that O in here, the O2, that guy had to get multiplied by 4 as well. 2 times 4 is going to give me 8. Okay, currently carbon are balanced. Next one, hydrogen. I have 10, 2 on this side. What can I multiply the 2 by to get me 10? 5. Now, I'm not writing 10 as the coefficient. I'm writing what I multiplied by, that 5. That 5 applies to the whole compound here. So this 1 down at the bottom, this 1 oxygen has to get multiplied by 5. So I have 4 carbon and 4 carbon. I have 10 hydrogen, 10 hydrogen. I only have 2 oxygen on this side. What is the total amount I have over here? 5 plus 8 is 13. 2 does not go into 13 evenly. So what we can do is call this a 1, and we can say, okay, we have 13 over 2. And then you guys remember that trick? Okay. Obviously, we can't have a half or a fraction or a decimal, but when everything else is balanced like that, then we wind up, to get rid of that half, we would double. So this 1 would become a 2. 13 halves times 2 would give me 13. 2 times 4 would give me 8. And then 2 times 5 would give me 10. So we have a 2, 13, 8, 10 ratio. This C4H10, guys, the name of that is butane. So when they're asking how many moles of butane, that would be B. And what are we starting with in letter A? 5.5 moles of oxygen.
Wait, so why would it be B for butane?
Because that's what we're looking for. They were in letter A, they said, okay, you have 5.5 moles of this substance. That's our starting point. That's letter A. Substance A for the easiest use of the chart.
Okay.
B is what we're wind up looking for, right? So we're always going to be like given one substance and asked to figure out how much of another that can get us.
I got you.
So you would go about this one, okay? They wanted us to figure out Uh, moles of butane, right? We're starting here. So we're starting at box 2 because we're starting with moles of substance A. So we're starting here. And they want us to find moles of substance B, which is right here. So that's it. This would be the only conversion that you need to make. Okay, the guys based off of their coefficients. So let's do the one that's a little bit more of a pain in the butt. Let's do letter B. All right, so in letter B, can you guys tell me what is our given? What do they give us? Good. 3.5 moles of oxygen, this O2 here. And what are we looking for? How many grams of carbon dioxide, or CO2? That is letter B. That is not the best B. Okay. So with that, I'm going to zoom out just for a hot second. We're starting in what? Substance A is starting with moles. So that means we're going to be starting here at box 2. They want grams of substance B, which would be here. Grams for substance B. Okay, so we know that these two yellow pieces here that are highlighted are going to be our conversions. They are going to be our conversions. So take what you're given, put it in the starting spot. 3.5 moles of O2. First step is, since we're starting here, we need to go and use this guy from the mole ratio. So our mole ratio was a 2, 13, 8, and 10. A 2, 13, 8, and 10. Moles of A on bottom. What substance was A? Was it O2 or carbon dioxide? O2 is substance A. So it says blank A on bottom. Mole A, substance A was O2. So we have to get out of oxygen to move into our next, all right, to move into the other substance. What do they want? It's carbon dioxide. That would be our substance B. So that dude is going to go on top. Mole of CO2. Where do these numbers come from? They come from the balanced equation. We had just done the equation where we had 2C4H10 plus 13O2 yields 8 carbon dioxide plus 10 H2O. So that would be looking here. All right. So what is the coefficient in front of the CO2? Well, all right. O2 would be 13. Okay. And then the CO2 would be 8. So that was our first conversion that we needed. Our second conversion is this dude here highlighted in yellow, where it says the molar mass of B over 1 mole of substance B. What was substance B again? Carbon dioxide. So we're going to write 1 mole of that on the bottom. In our like chart here, after we did this conversion, which was this piece, to convert this into grams, we need to cancel out this unit of moles of carbon dioxide. So 1 mole of that goes on bottom, and now we just need to know what the molar mass of CO2 is. So instead of having to make the little table for molar mass, we can kind of simplify or streamline this a little bit. So I'm going to show that right now. I do it off to the side. CO2. Okay, the first element that you come across, we're going to throw up a little parenthesis. What is the mass of carbon when we look on our periodic table?
12.01.
Good, 12.01. So I'm going to write that here. Are there any more, or is there, how many carbons are there? Just one, right?
Yeah.
So then I'm going to close that parenthesis. Is there another element in here?
Yes.
So then I'm going to add a plus sign. What is the next element? All right, the next element is oxygen. So I look up its mass on the periodic table, and we got 16. So this is the mass of that guy. But how many oxygens do we have? So you're going to do times 2. All right, and now we're done with the oxygen, so we close the parenthesis. Are there any more elements in here? No, so we don't need another plus sign. We would then just equal that out. So 32 plus the 12.01, and we're going to get 44.01 grams per mole of CO2. This is your molar mass for that substance. So that number here is going to go there on that yellow chart, right? So molar mass is above that 1 mole, so we have to have our 44.01 grams of CO2. Now the units that we don't need should cancel. Moles of O2 on top, on bottom, good. Moles of CO2 on top and bottom, good. Only unit that didn't get canceled out is what we wanted, grams of carbon dioxide. So calculator, multiply everybody on top. 3.5 times 8 times 44.01 equals, divide by 13. You don't need to divide by 1 or multiply by 1 because it doesn't change the number. And so 1, 2, 3, multiply together, divide by 13, and you should get an answer of 94.79, and that will be grams of CO2. Excuse me. Now, we will do only other thing I think we should really need per se. All right, you guys should be solid on the rest of these. As long as you are able to identify A and B, and you have these things highlighted, okay, and you know where you're starting, either in box 1 or 2, where you're going, it tells you what to do for the conversions. The hardest other part may be to look up or calculate the molar mass. But yeah, other than that, you should be good. I just want to make sure that we have the next two things balanced. All right, so on the back, we have MgHCl yields MgCl2 plus H2. So we have 1 magnesium, 2 chlorine. We need a 2 here. That 2 is going to give me 2 chlorine, which work, plus 2 hydrogen, which is good over here. So we have a 1, 2, 1, 1 ratio. And then in number 4, okay, if we're balancing number 4, we have N, 1 of them, H, we have 3 of them, we have O, 2 of them. On this side, we have N, 2 of them, H, 2 of them, O, 1 of them. Well, right now the H's don't balance. 3 and 2, the closest dude they share is a 6. So I'm going to multiply this thing by 2 to give me 6. It's what you multiply that becomes the coefficient. The coefficient applies to the whole compound in front of it or behind it. So 2 times the 1 here, it's going to give me 2 nitrogen. Okay, so right now that works because the nitrogens are balanced now, 2 and 2. Hydrogen's up. Well, if this is going to be a 6, we have to multiply this dude by a 3. So what we multiply, that becomes our coefficient. The 3 now applies to not just the H, but the O. So nitrogens are balanced, hydrogens are balanced, oxygens are not. Is there any number times 2 that can give me 1.3? Not a whole number. Yep, 1.1. Or I'm sorry, 1.5. So you can do it as 1.5, or you can do the 3 over 2. Either way works. So if I just showed it like this, I would have to have 1.5 here as my coefficient, and there was nothing in front of the 1, or nothing in front of the N2, so I would just say it's 1. This is not okay, the 0.5. So to get rid of that, you have to double it. And you can't just double one of the coefficients, you have to double all of them. So we throw up a little parenthesis around the outside. Put a 2 there. 2 times 2 is how many? So this coefficient is going to be 4. 2 times 1.5. 2 times 1. And then 2 times 3. So you're looking at a 4:3 to 6 ratio. All right, so what I want to make sure you guys are good with, underline, all right, your A's, what you're given, that substance, what you're looking for, that is going to be substance B, and then make sure you use, okay, your mole map, and it will help. And please do them in order, don't do them out of order. So for example, I had someone in my one class, they were going from 2 to 4, right? So you needed these 2 conversions here. They did this one first, then this one, which is, at least for me, very confusing. Technically, if everything works or gets canceled out, that doesn't need to be there. Problem still would work, but as far as line of thinking goes, okay, follow it in your order. All right, and get started.